Hey guys, I'm just another engineer, and welcome back to some more Turbo Snail construction. Now, I know it has been quite a long time, that's because school was getting kind of busy towards the end of the year, but now it's summer, and I have all the time in the world to record more of these things. So we should be finishing up kind of soon, because we're on episode 11 now, and we're working on conditional jumps this episode. So we're going to be, first of all, getting in the flags register, because we don't have that yet. And then we will be getting jump if negative, jump if zero, jump if positive, and jump if carry. So the first thing we need to do is make the flags register. Now I'm making this custom made because, well, the registers that I normally have are really big and bulky, and I've just realized that they're not actually built that well, so, things to improve on in the next one. So I'm just wiring up a simple XOR bit and taking it out so I can actually see what's happening. Just wiring this up. I would like to do registers more like this because I kind of messed up in the old ones, or the current registers, where I had some weird circuitry where I had to reset it and then write it. I didn't realize I could just use an XOR gate, which is kind of ironic because it's XOR memory, and I didn't notice that. So here we're just testing it. I hooked that up to the wrong input, didn't quite understand how this actually worked yet. And here, when trying to stop it from flashing, I messed up the wiring. I forgot to reconnect a bit, so we'll see that bug a bit later. But just connect up a button to the right and then to the inputs, and you can see I can choose whatever one I want, and then it just resets. So save this and connect up an input gate. There we are. Save this to the flags register, and then move it over here for once I've actually planned on where to put it and not just welded it somewhere on the ground. So mark that up with paint and then weld it in place. And then here I'm just color coding it so it's negative, zero, positive, and overflow. And then just connect up the overflow bit and the negative bit. And then here I just need to connect every single output bit into an OR gate, so I'll just speed that up there. And then this is checking if it's positive, so if any of them are on, then that'll trip. And then I have an OR gate to make sure that if none of them are on, then it'll be zero. Now here I'm going to be testing the outputs. I've already wired up some buttons to be able to bypass the ALU stuff, so I can test that. So there's one, or that is positive, that's zero. Here we're testing negative. I messed up that because I left the bus on. That's negative, and then here is overflow. Do that, and then here's where this bug comes into play. First of all, I mess around there, and right there it doesn't want to reset because I didn't reconnect the reading for the XOR gate to figure out whether or not it should toggle. It takes me a while to figure this out because, again, this is new for me because I haven't done this in like 4 or 5 months. So I'll figure that out. Now we're going to be doing some jump hardware. So first of all, I need to change around the ops codes because these are different. Because I actually forgot to include jump if overflow, which makes it weird because then there's 5 jump commands. So then I just move down the data sharing because I'm honestly not sure if I'm even going to be able to do that. But I'll at least try, but we don't need that many ops codes, so we can spread them out. Here I'm just connecting up all of the gates, and since they're all basically the exact same, the only difference between them is which which flag we're checking. So I just make them all at the same time, and there I'm just flipping the stuff in the documentation to make it actually align with the flags, just because you don't want it to be backwards from what the actual hardware is. So there, just wire in the flags into the AND gates to make sure that it only goes off once the flag is set. And then if that does go off, it'll do the exact same thing as the regular unconditional jump. And if that doesn't, then that won't ever happen, and then it'll go to the next step, and then it will just pretend it's a no-op. So if the flag is on, it'll do the jump to the location, and you saw there I went to the control board and hooked up step counter in, pretty sure. I keep forgetting the names of these things. But and then the second gate on the top, just connect that up to the advance and reset. And that's all the hardware done. So now comes the test software to make sure that everything works. So I'm just writing a simple program to subtract 1 from 5, and then it'll go 5, 4, 3, 2, 1, 0, and then -1, and then it'll jump. So a bit weird writing this out because I haven't actually written programs for this thing yet, so kind of forget how to do it. And here I've actually messed up the addresses because if you look at the top, I start from 1, but the addressing should actually start from 0. So it takes me a while to figure this out, but there we go, just programming this in. It does take quite a while, but I will be adding in a disk drive pretty soon. And I've actually worked with a sort of hard disk. The thing I'm thinking about adding in is sort of like a floppy disk reader, so you can insert a cartridge. It's 16 addresses of 16 bytes, so 256 bits. And now you can see debug mode now because stuff is going horribly wrong. So I have a floppy disk that I'll be able to put in so that I can save a cartridge and scan that in, so it'll go a heck of a lot faster for repeating stuff. And then I've also worked on a hard disk with friends, which is spud guns and switches, and that goes up to, I think it might be 8 bits of addresses. I'm not sure, but it's a lot of addresses. Oh, and then here I found there was a dead bit. I don't know what happened. Just one of the bits wasn't working for some reason, so went through a whole bunch of tests, tried to see if it was connected up to the wrong thing, and then just eventually decided, hey, this actually isn't that complicated, so I just removed the gate. So right about here, just checking to make sure that it's only one connection. Reconnect it, and now it works, I'm pretty sure. There, and then go and test it, and it's horribly wrong. So go and start checking this, and I realized that the ALU is actually going too fast, or sorry, too slow. The clock is going too fast, so it needs a few extra steps because the subtraction kind of freaks out. You saw it got like a really big number. That's because it didn't have enough time to ripple down. And it's still going wrong, so still more debugging, and I think here I sort of just give up and decide to stop the recording because it would take forever to do this on camera. There we are. So now I think that I've actually got it. Forgot to reset the memory here, something went wrong. And try it again. Subtract works. And subtraction works. And then here I notice that the control word is freaking out. That's because I actually wired it up incorrectly, but first I check the addition and the subtraction because that's the only thing that's wired into it. And I've had this issue before with the Javelin where it was messed up, but there was another issue with that. And so here I'm just making it so that it's 2 minus 1, so it doesn't take forever because the clock is pretty slow for testing. And then here, it kind of works, but doesn't really. So the issue here was that the conditional jump, it was going so fast that it sort of skipped over, or there was a bit of a race condition, so the jump itself and the no-op was sort of happening at the same time because the jump took too long to go through. So there I just added a bit more delay, and then here you can see still not working. I think it's here, yeah, here I add some more delay. So I'm just making it so that the jump actually has enough time to process because I'm pretty sure there's a pretty big delay on that timer. I should probably reduce that, but I just had it high for testing to make sure it would work. And then here, it actually stops. Yay. So now back to testing. Now we're actually going to be checking the 0. So I just copy the instructions and change some things. So I change it to be jump if 0, and then also change it to be 3 so that there's a few more steps before the jump, just to make sure that it doesn't go off when it shouldn't. And then here I just check all of the bytes, or not bytes, addresses to make sure that everything's correct. Just change the stuff that needs to be changed. And this will go a lot faster in the future. I don't know if I'm going to write my own compiler in Python or something. That would be interesting to be able to make a compiler and then make it modify the sort of disks that I can pop into the disk scanner. But that's pretty advanced, so I might not be able to do that. But here we go. And it works first try because it is basically the exact same thing. And there it is, terminate. So that's just about everything. We've got our flags register, we've got our conditional jumps. I still need to speed up the clock, but I think I'll do that after we're done with all of our instructions. The next thing we're going to need to do is get all the Boolean operators. So I want to be able to compare the two registers and apply all of these, basically just the logic gates. So that should be pretty easy. Just get a line of gates, put an output for an and then pass it through. So that shouldn't be too hard. And then maybe the device sharing, I would like to get that. Then I'll try and speed up the clock, get a disk reader in, maybe that hard drive, so we'll be able to get even more addresses, but I think we might encounter some issues with lag at that point, because already, I mean, if you look at the top right, we are at 60 FPS, but if I take out my connection tool, that drops very, very quickly. So hopefully the game doesn't freak out. Might be able to add more memory to actually make this pretty darn usable and maybe get some RAM-ROM interaction rather than just manually programming the RAM. But yeah, that's just about it. So I will see you guys next time.